guys, this is Ryan Linfield with Stormwind. Just this past weekend, I did a talk at B-Sides. I actually did two. One on IPv6 man-in-the-middle attacks, which I might get around to releasing a video of later, and the talk that's behind me here, igniting, what is it called? Igniting Firewalls. And I think officially the title was Igniting Firewalls and Friends, but trying to keep this politically correct because I got my Stormwind logo on here. So the talk was originally going to feature some 0 days, and I had some stuff in here about implant kits that the NSA was using. But I go, you know what? That's not going to win me any points with any of the vendors, and I don't really need to climb any higher on the CIA or NSA or any of the three-letter agencies' watch lists. So the top secret stuff is out there. You can Google for it and find it on the leak sites. I'm just going to give you my general presentation here, which doesn't have 0 days, which doesn't have any top secret stuff. You got to find that on your own. But I'll show you where to look. So let's go ahead and get started with this. So, like I said, the talk was called Igniting Firewalls, or more specifically, Igniting Firewalls and Friends. I opened up with this, who am I, which basically I just disclosed that I do all my training. All of my Cisco delivery is now through Stormwind, and we do some technology consulting services under the name Westchase Technologies. So myself, Desiree, Ralph, and Rob, the four of us knock out everything from UCS installs to pen tests to voice over IP, you name it. So the pitch, for anybody who's interested, or you're curious of what the heck did I just click on, this is my kind of view of firewalls today. What do they do for the good guys? What do they do for the bad guys? And we just kind of want to kind of understand them a little bit better so that we can either attack more effectively or defend ourselves more effectively. So at this point, 2014, I would say that firewalls are ubiquitous. Everywhere that you look, we have firewalls, and they're not crummy. It's not a Linksys, it's not a Netgear, it's not a SonicWall. At least I hope it isn't. What you do have, and I'm like, I've got friends at Dell. I shouldn't have said that about SonicWall. Anyhow, what you do have, if you've got the Checkpoint, the Palo Alto, the Cisco, ASAs, etc., are you going to have features like deep packet inspection? Sometimes we bolt on a web application filter, or maybe it's built in. I know I've got some clients that have F5s, and they've got an additional module which does some application inspection. They're going to do protocol analysis, and these are some of the things we'll talk about throughout the talk, but basically they're more effective than ever. They're getting stronger, they're getting more intelligent. So from an attacking perspective, if I'm looking at a Fortune 100 company, or I'm looking at maybe a competitor, and I want to, break into their systems, and this is me pretending to be an attacker. I want to break into their systems, and I want to look at their email, and I want to see what they're quoting my clients or the people that we're competing for business with. I want to see what those guys are doing. If they have an intelligent firewall, it's going to be much more difficult to get into those systems. So what can we do about that? And like I said, this talk is going to be something for absolutely everyone. I'm going to put on my black hat and talk about this is the offensive side to bypass it. And then when appropriate, I'll put on the white hat and say this is what you guys should be doing, because I know most people watching this are my students, which have day jobs, which are, they have employers that of course they want to protect. Those are the things that, what can you do to keep the bad guys out? So I'll try to show you a bit about that. Before we get into too much of an in-depth discussion, let's just start at a high level and say, what is a firewall to start with? So what is a firewall exactly? Kind of a funny story. A while back, my wife and I were going to meet some good friends, and I had to call them and postpone dinner by about 2 hours. Now, our friends, as wonderful and delightful as they are unfortunately early birds and not real big partiers. So when I said I had to push dinner from 6 o'clock to 8 o'clock, he starts sweating. He's like, oh my gosh, dinner at 8 p.m., what are we going to do? So I said, well, it's just this customer's firewall. I've got to get it sorted out. And he's like, well, I'm by your house. I can just swing in. Is there anything I can do to help? Now, my friend, and I can say this because he'll probably never watch anything like this. He's using like an old Earthlink account. He's not on dial-up, fortunately, but he's the least technically savvy person that I know. Great human being, but just not much of a tech head. And I go, Chris does commercial construction. He's a general contractor. He builds great things, but he doesn't know a lot about technology. What was he thinking when he just said he was going to help me with a firewall? And at that moment, when I probably should have been thinking about what's going on with our packet, as it's being processed by the ASA, I'm thinking, what does Chris know about firewalls? And what had occurred to me at that moment, having passed multiple firewall certifications and spent a lot of time configuring them and a lot of time in security, and actually wrote a book on firewalls for Cisco Press, it hit me at that moment that I was like, wait a minute, a firewall stops a fire from spreading. Why didn't I get that before? You have them in commercial implementations, like in a mall. You'll have a couple different stores, and there's a firewall out. And if Williams-Sonoma, somebody's in there doing a cooking event, and they catch the whole place on fire, we want to make sure that the fire reaches a certain point and it just kind of hovers there, so we've got time to put it out before it spreads any further. Same thing if you've got a car, right? Most of us have cars. If you've got a car between you and the engine where there's ignition and where a fire could break out, we've got that firewall to separate the two of us and keep us safe. So it's not really much different when we look at your network and you have a firewall there as well. The firewall in your network, again, is intended for containment. So when you design your topology, and this is just a typical, very basic implementation where they say, we've got this three-legged firewall. You basically have the inside, you have the outside, and then you have the DMZ. Of course, traffic can come in from the internet, and it can reach our web server or mail server, which is going to be how we communicate with people. And then your web server or mail server is going to talk to something back on the back end, typically a little bit more interesting and juicy, like an SQL server, which you could have patient health information, you could have credit card data, you could have the secret cookie recipe, whatever it is that's valuable to you tends to live in a database, and we like to isolate it from the web server. Problem is, of course, if this web server gets compromised, he has unrestricted access to other devices, and he's going to attack those as well. So that's what a firewall is. So who is this intended for? Well, I can't speak to firewalls, but I can speak to firewall administrators. So what is your job? What does a firewall administrator actually do? Back in 2004, your job was to open and close ports. Someone would come to you and say, my application can't go through the firewall. And you would say, well, I am the firewall administrator. Let me see what I can do about that. And you would pull these levers here. You would basically just go in and say, I'm going to open port 80, or I'm going to open port 443, and I'm going to shut 135. And you would open and close the floodgates as needed. That was 1994. That was basically how things were working in, 2004. And I just picked that number because it was about 10 years ago. But fast forward to today, what are people actually doing with their firewalls? Well, I was looking through Google Images for great pictures. I hope I didn't upset any three-letter agencies by borrowing this one. But this is just kind of like an advertising picture for a ballistic missile defense system. And they're showing all these advanced defense components that they use, from satellites to radars to, ships with radars on them, and, anti-defense missiles to shoot down other missiles. And it's very complex, it's very exciting, and that's what our firewalls are almost like today. We still have good old port filtering that we could utilize with access control lists, but we also have virtual firewalls, or what in the Cisco world with the ASA we describe as a context. So I could take my physical firewall, like maybe a 5515X, and I could divide it into one context for dev and one context for production. So it's one physical box that has multiple virtual firewalls. And you can have dozens and dozens of virtual firewalls depending on the physical appliance. And it's not just Cisco, other vendors are doing this as well. Additionally, we've got things like the ASAV. And again, Cisco's not the only person creating a virtual firewall, but this is a virtual firewall that we can install into our virtualized environment. Not only ESX, but also Hyper-V. And it's coming soon for some of the other hypervisors that are out there. We've got features like clientless SSL VPN. A lot of customers of ours love this because they don't have to install the AnyConnect client. They don't have to worry about permissions on the end station. All the user has to do is type in a URL, authenticate with their Active Directory credentials, and boom, they're presented a login screen. They've got hyperlinks to internal resources, and the firewall's handling all of this. So you go, wait a minute, when did we go from being the firewall that separated fires from going from the inside to the outside, or the which I guess we're more worried about the outside coming to the inside, or the DMZ spreading to the inside? How did we go from isolating and containing and quarantining problems, and we started putting all these bells and whistles on top of it? Well, Cisco, for instance, used to have their PICS line, and they used to have their VPN concentrators, and they molded those into a single product. It's great, but when you look at a product and it starts doing more and more things, you have to go, wait a minute, isn't that more things that could break? My current car is fancier than any of the other cars I've ever had before. It's got all this intelligence, like it can sense rain hitting the windshield, it can sense that it's dark out. It's even got little eyeballs in the bumper that can see the paint in the road, and if you're weaving or you're getting too close to the paint, it shakes the steering wheel and goes, hey, pay attention. Which is cool, except for when things happen, like I would be parked at a light and my steering wheel would shake at me. It'd be like, pay attention. And I was like, I'm paying attention. I'm paying attention to my phone, waiting for the light to turn green. Just kind of going through some emails here, but I'm watching. I'm not even moving. Why is it shaking at me? So, took it back to the dealership and they go, oh, it needs a software upgrade and it's going to fix that. I thought, oh no, now I've got bugs in my car, just like I've got bugs in my phone and bugs in my Xbox and everywhere else. So as these features start to compound, the landscape changes dramatically. We've got a lot more room for error conditions to occur. And that's what this talk is really about. Remember, from a hacking perspective, we want to ignite the firewall. We don't want it to be able to stop the fire. We want to tear it down. So when you look at the list of features that I have here, there's different ways to look at it. Yes, you're getting more for your dollar because your firewall can do so many different features. But in addition to all those crazy features that it can do, again, like tweaking TCP performance parameters, doing deep packet inspection, doing web application filtering, IPS threat detection, protocol identification, botnet detection, passive OS fingerprinting, the list almost never ends. We add all these features, and you go, you know what, that's just a lot of different things that could be attacked. Now, from the hacking perspective, before you really think about hacking firewalls, if you're just a hacker and you want to land an attack, it's not a good time anymore. Here's this guy, he's got this brand new 0-day, which could take down this web server of a target, and he can't land the 0-day. The idea is that this firewall that does the protocol inspection, that does the deep packet inspection, is actually looking inside the payload. What I always do in my classes is I say whether it's layer 2, layer 3, or layer 4, it's just an envelope. This is a container that's going to get my message to a destination. Well, of course, if we have an exploit, most of the time the exploit tends to be in the payload. So I'm trying to target an FTP server or a web server, at least if I'm doing, remote exploitation. And the firewall keeps identifying this. And he says, you know what, that's no good. And he keeps throwing away my attack. There's actually signatures in Cisco's IPS that can detect, hey, this is some payload that was created with Metasploit. Of course, there's ways to obfuscate that, but it's just this game of chess that goes back and forth. So here we have just kind of like another scenario. We've got the attacker on the outside. Looks a little bit like Kimball from Kim.com, I think. He's going to send this evil packet to the inside. He's trying to land it, but unfortunately, the firewall can identify the hostile payload, again, by looking inside of the packet, looking at the contents here. And if you're a good firewall administrator, you can get into the guts of this and you can lock down HTTP. You can lock down SIP, you can lock down H323, and you can whitelist only the features that are absolutely required, making it very difficult for this guy to launch his attacks. So that's what kind of got me thinking we need to have a new way. This is what I see when I'm looking at trying to land an exploit on a system that's protected by the firewall. I got this great exploit and it keeps airing out. I try it in the lab on the exact same version of the server and it's like denied, 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 and you get frustrated. So when hackers get frustrated, they typically resort to denial of service. Now, what we're going to do real quick is define what is a DOS versus what is a DDoS. Well, DDoS is what we heard a lot about last week. There's a hot new off the press NTP attack that all the kids are doing, where it's a reflection attack that results in about just over 58 times the amount of data that you send out can be reflected at somebody else. That is, if I were to generate 1 meg of outbound data of UDP requests, and this is just looking for time synchronization, the way that the attack works is that I'm going to hit lots and lots of different servers and forge a ton of requests from a particular user, let's say you. So your computer's sitting there twiddling its thumbs, you're on your Xbox One playing Call of Duty, and all of a sudden you experience a ton of latency. And you're about to snipe somebody in Call of Duty, and then all of a sudden your connection gets really, really laggy and you get dropped. You go, what the heck is going on? And it keeps happening. So you bring out a protocol analyzer thinking it's something wrong with those crazy guys at Bright House or Comcast. And what you notice is that you've got this huge plethora of NTP responses coming at you. Well, again, with that ratio of that 1 meg out to 58 down, what if you've got 10 megs out? What if you've got Verizon Fios and you've got, I don't know, 100 megs out? You can generate 6 gigs of data towards somebody else. Now, what if you rent a botnet for something like, I've seen people advertising their Zeus botnet with 12,000 compromised systems, and they'll rent it out for like $3 an hour. You take a system like that, you use 12,000 hosts to launch this NTP attack, and then you start to see some really significant quantities of data. For example, Cloudflare got hit with something like 400 gigs of traffic last week. So just massive, massive traffic. Will that drop the target site? Yes. Will it give the hacker a little bit of satisfaction because he couldn't get through the firewall and he got sick of being told no? Yeah, but I don't know. It's not my ideal situation. That's where we're going to move from distributed DOS attacks to a targeted DOS attack. So what the heck is a targeted DOS attack? This is where we create a single malicious packet, and it could even just be a couple of them, but this is a packet that I could, go ahead and just load up Python on my cell phone. I could generate a script in Python that's going to send this packet out, and from my cell phone at any point, I could just send out one little packet or a few little packets that is not going to chew up my data subscription on my phone, and I could drop systems left and right. The way that we do this is we need to find what we refer to as just the exception to the rule, or a vulnerability within an application. We're going to create a custom packet that wouldn't normally exist with some arbitrary values in here that causes the firewall to crash. And by sending that one custom malformed packet, the firewall drops offline. So, for example, this is what I see myself doing, just kind of running through the firewall and crushing the heck out of it. There I was at one moment trying to get my attack to go through the firewall and hit the web server, and it was denied. And I go, all right, let's just go into Kool-Aid mode and just crush the wall altogether. This is at least the mental image that I got the first time that I got my attack to work. I was just this excited, and I was probably saying, oh yeah, at the top of my voice. So that's what I had. Now, for some of you out there, I've got students at all different levels. I've got guys that are just kind of breaking into the security field that are career changers, or maybe just into the networking field working on a CCNA. I've actually traded a lot of guys that work for three-letter agencies, even right here in Tampa, Florida, working for Cyber Command, attacking other nation states, going back and forth. And if I was to talk to them about this, they'd say, well, isn't a DOS attack kind of lame? And I say, well, this is something that if you feel so inclined to do, you could take something and find your event that you can use to trigger the firewall to crash and work with it, mold it, see if it's something that you could actually turn it into remote code execution. And in that circumstance, you could actually run your own code on the firewall and possibly put a rootkit, if you could build one of those, into the firewall as well. Now, this is something that has been possible from a speculative nature, but I'm not a developer and I don't do assembly and I don't, reverse engineer to that level. If I can crash the firewall, that's where I get excited with my Kool-Aid, my little Kool-Aid guy, and I shut off. So if you look at most modern firewalls, they're based on Linux, they use Intel processors, they borrow common libraries, and if we understand Linux exploitation, which is well documented all over the web, we could possibly build our own attacks that would give us root access or admin control of that firewall. And we could possibly even inject code to have a persistent rootkit effectively on that device. Now, some documentation is going to call that an implant, and I didn't want to put any of the NSA docs that Snowden leaked into my slideshow because I kind of like my life, I like my dog, I like my wife, I like my video games, and I don't want anybody coming and taking me away. So if you're interested in that kind of thing, I can't show it to you here. Just look for JetPlow and Bananacly, which are two of the NSA rootkits that they used on Cisco firewalls. Now, there's things out there for Checkpoint, there's things out there for Juniper, but again, I was really targeting the ASA. So we talk about proof of concept code. This is literally proof that you could install a rootkit on a firewall, which is pretty exciting, at least for me. So what's going on under the hood of a firewall? Well, for the most part, we talk about stateful packet inspection. That's our first level of saying, what kind of firewall are we working with? Is it a simple packet filter, or does it do stateful packet inspection? Well, to break that up a little bit better, TCP, of course, is stateful. We have a beginning, which is a three-way handshake. We have the middle, which is data being traversed back and forth, and the sequence numbers climb. And then we've got the end, where there's fins and resets and the session is torn down. So what your firewall can do is he can look at the TCP sequence numbers, and he can kind of predict or forecast about where they're going to land. So if this TCP packet comes out of the blue with a sequence number that's way the heck off, it could suggest that someone's possibly trying to do a blind TCP hijack. Firewall would see that, go, those sequence numbers are no good, throw it away. Additionally, he's doing things like looking at the beginning of the connection and saying, is there a SYN, ACK, and then an ACK? If not, the rest of the session isn't going to be valid. He's going to do things like sequence number randomization. And one of the things that's kind of cool is if you're monitoring traffic, say you're just in promiscuous mode, looking at a wireless network, seeing packets flow through the air, we can look at the TCP handshake at the beginning, and we can look at some of the parameters that are used, and we can identify that this TCP session is actually being established by a Linux host talking to a Windows host, or vice versa, or Windows to Windows, all by parameters that are used within TCP. One of the things that it looks at is called the initial sequence number. One of the pieces that the ASA does to help mitigate passive OS fingerprinting is sequence number randomization. Whenever packets go through your firewall, there's a good chance that they're going to be natted. One of the other things that he does while he's in there, he's like, well, I'm changing the IP address, I'm changing the port number because there was a conflict. You wanted to use port 1025, but Bob over here was already using that to go to ESPN. So we're going to scribble out and rearrange your port number. And what the heck? While I'm in here, you tried to use an initial sequence number of 1024. I'm going to move that to 1537, just to throw anybody off who might be watching. These are things that he does behind the scene. He implements SYN cookies, which kind of like an old school thing. It has to do with SYN floods and mitigating those. It's baked into the Linux kernel. Everybody's doing it these days. But that's not the surprising part. I think the surprising part is that they say that you can do stateful inspection of both UDP and ICMP, which that's a little bit weird. You go, how do you do stateful inspection of something that is not stateful? And what it actually does is it just implements some stricter timeouts. You know, UDP doesn't have really a teardown because it's not stateful, of course. So we monitor UDP traffic. And if it goes quiet after something like 30 seconds, we go, they're not talking anymore. Go ahead and tear that down. And then specifically, when you look at things like DNS, he's smart enough to look at like a DNS request and a reply. So you send a request out to some DNS server. The firewall, who's got this force field dropping packets that comes in, goes, you know what? We're going to open a little hole in the force field for the DNS reply to come in. He lets the reply in and then instantly closes that hole and says, okay, no more replies. So the firewall is getting smarter about the traffic that he allows. ICMP the same way. ICMP echo request goes out, he's going to allow one echo reply to come in. As soon as that's done, no more echo replies come in. So he has more granular control over the packets. And the way that he does this is by having a little bit greater intelligence about what's going back and forth. Cool. So that's just our TCP, UDP, and ICMP. Still not that great. What else are firewalls doing us for today? Well, they're pretty slick. They've got some decent trickery. One piece that's kind of neat is TTL deprecation. We learn that with TCP, every time our packet goes from one router to the next router to the next router, that the TTL will be dropped, maybe from 64 to 63 to 62, and so forth. Should you go through a firewall, he tries to hide himself by not dropping the time to live. And this was to mitigate a scanning technique called firewalking, to make it a little bit more difficult. Additionally, he can do things like banner spoofing. Whenever a client connects to a server, the server tends to announce himself. He says, hello, I'm Exchange version 2013. The firewall can scribble out that reply and go, no, you're not. So this is him trying to say, I'm Exchange 2013. And the firewall goes, no, it isn't. It's SendMail. Version 1. 1.0. Just to kind of mess with whoever might be using this for nefarious purposes. Like I said, of course, he does that TCP sequence number randomization. And one of the tricks that I've done, it's really not that clever or special, but hey, if you're not doing it, here you have it, is forging your MAC addresses. I first did this for a university because they had as many attackers on the inside as they did on the outside. They had constantly had computer science students trying to break things, trying to hack things. So while we didn't have a management interface on our firewall, you could look at the OUI of the MAC address and you could say, oh, that's an F5 device, or oh, that's a Cisco device, or oh, that's Checkpoint. So you could forge the MAC address, and if this is a Checkpoint firewall, you change it and you give it the OUI of a Cisco firewall, just to kind of throw people off. So not that this is anything that's special, but it's just things to kind of realize that this is what you might be up against if you were one to attack a firewall. Or again, for the white hats out there, this is something you could do to maybe just protect people from identifying your firewall. Putting my black hat back on, if I wanted to target some organization and I wanted to identify what type of firewall they're using, one of the easiest ways to do this, can you guess what this is? I would look for job postings. Because a lot of times they're going to ask for somebody with Checkpoint experience, or they want a guy who knows Palo Alto. So if I see that in a job description, my OS identification of the firewall is going to be done. Now, another piece that's pretty exciting with firewalls is this stealth mode. Now, the first time I encountered stealth mode, or at least a practical application for it, it was for a hospital that had an MRI machine that was, I don't know, millions of dollars. And the software that ran the MRI machine only ran on Windows 2000 Server, and if they patched it beyond, I think it was Service Pack 4 or something, the software patch for Windows broke the MRI software that managed this extremely expensive piece of medical hardware. So they had to roll back the patch and reinstall the software and sort it all out, and they're like, all right, nobody ever patched this box, which is fine until they need to pass an audit. And they go, well, we're going to have an audit done, and we need to pass the audit. And I go, okay, we need to get rid of that server or patch it. And they're like, well, for business case, there's no business case for that. The device works just perfectly, the software works perfectly, but we can't patch the OS. And I go, well, it's you're at a fork in the road, and you got to go one way or the other. And they said, neither way, we need to pass the audit, and we're not patching. And I thought, what can we do? So I wanted to install a firewall, but there were other pieces of software that interacted with this application, and all the IP addressing was hard-coded by the engineers that wrote it, who this software firm is no longer in business. So I was like, great, I've got clients over here that can patch. I have a server on the other side that can't patch. And when I'm looking at the two, I'm like, well, how can I was hoping to put a firewall with an IPS in there to look for the attacks and do some filtering without changing. What I had to do was do this without changing any of the IP addressing. Normally we had a firewall and we've got different subnets on either side. What I had to use was what we call stealth mode or transparent mode. And what transparent mode is going to do is drop that firewall in the middle, and we have the same address space. In this example, it's just 192.168.1.0 on either side, and our firewall is acting as a bridge. Now, the first firewall that I saw that could do this, to my knowledge, was NetScreen, but this is a more common feature that we're seeing on more and more firewalls today. So even though he's a bridge and he's forwarding based on MAC addresses, we still have the capabilities to perform that deep packet inspection and perform IPS functions. So I can get into the guts of things like DCE, distributed computing environment remote procedure calls, or HTTP, or whatever application that it is, I'm going to have some visibility on. So very, very powerful. These are the types of things that we can use for the good guys. Now, for the bad guys, what can they do? Well, we want to take a look at what's the firewall doing that maybe it doesn't necessarily need to do, or what's outside of its core set of responsibilities. And one of the main things that comes to mind for me is routing functions. Whenever I teach firewall classes and we go into a routing section, I've always got at least one student that's like, I don't want routing protocols on my firewall, I just want it to filter. And that's kind of a good mindset. You go, I want my firewall to be a firewall, my switch to be a switch, and my router to be a router. But for practicality purposes, this isn't always possible. For instance, remember that our firewall is not just a firewall anymore. We're doing these VPN connections. And I might have multiple firewalls, and I'm doing some clustering. So as different remote users are coming in to different firewalls and they're connecting, I assign an IP address to the remote user. I then need to do something called reverse route injection, where I tell devices on the inside of my network, my switches and my routers, I can say, hey, 172.16.5 just got assigned to the accountant, and she's logged in remotely, and it's over here on this ASA. So your firewalls need to communicate with the internal network and tell them, hey, this is what's going on. Additionally, when you make changes to your internal network, your firewall does have a routing table. He's got a default route that points to the internet. He's got some internal routes that point over here. Every time you add a new subnet for wireless, or for a new, maybe for a new SSID, or maybe in a lab for testing, or maybe for a new floor, you have to go to your firewall and say, hey, this other network is on the inside. Send those packets that way. Well, of course, with the dynamic routing protocol, we can update the firewall and let them know about the new SSID that we just deployed in our wireless network. So there's good reason today to run routing protocols on our firewall, but from an attacking perspective, this is something that, of course, can also be leveraged against the firewall administrator. So let's take a look at how that would work. So here we go. Like I said, most modern firewalls support routing protocols. You would expect to see OSPF, in my opinion. So if you're looking for something, I would watch for that. There could be some RIP out there. Probably, more than likely, you're going to run into EIGRP as the second most common. And there's firewalls that can do BGP. Cisco can't. I believe the NetScreens can. But I still haven't seen, and this is just me personally, I haven't run across anybody who really needed BGP on their firewall. So OSPF is probably going to be the most common, but it's also the most, I don't know, easy to get our hands on. I'll show you an example of why in a bit. The reason that we run it is, of course, to adapt to changes within our internal network and advertise reachability of remote VPN users. So like I said, there are some good reasons to do this. So one of the things that I could kind of see happening is we compromise a host on the inside of the network. OSPF is going to be on the left side, probably not on the outside, unless they're doing some type of advertising with their service provider, but I don't know. Probably going to find it over here. Now, if I could run TCP dump for 10 seconds on this host, that would be long enough under typical conditions to see at least one OSPF hello. And if we see that OSPF hello come in, I could look at that hello and I know everything that I need to know. I can see the hello and dead timers. I can see the area ID. I can see whether or not authentication is enabled. And most times it's not, which makes us so powerful. If authentication is not enabled, so this is the piece for you white hat guys. If you're running a firewall and you're running a routing protocol, make triple sure, check it 3 times, make sure that you have authentication enabled, and make sure that it's MD5. The danger is that this could be a Windows, a Linux, or even an OSPF host. And if this, OSX, too many O's. If that could be an OSX host, and guess what these guys have in common? They're all capable of doing OSPF. So if someone compromises the system, they run TCP dump for 10 seconds, which again, to play devil's advocate, running TCP dump is enough to get you busted. You put that network card in promiscuous mode, especially if it's a VM, which most things are today, you could have a policy that would either block it, saying you're not allowed to go in promiscuous mode and we're going to generate a log notification, therefore you're busted, or alternatively, it could be blocked or you could get caught. But if that's not the case, which a lot of times it isn't, we can sniff long enough to learn about the network. We can figure out that OSPF should be enabled. EIGRP is going to be challenging. BGP, not a lot of support for it within your operating systems, not Windows anyhow. But what we could do at that point is form an adjacency with that firewall. We can start injecting some routes and then we can man in the middle of the traffic. So just one way to kind of leverage the firewall that's there to protect the company, we can actually leverage it against the company. So kind of neat and something kind of scary depending on which side of the fence you're actually on. All right, so I've got this old classic picture, and this is not a cool meme, right? This is, from hackers back in the 90s. But you've got this guy, and we know how, kind of goofy the hacking attacks were in the actual Hackers movie. And he's like, hey, bro, you should totally send some traffic this way. Yeah. And we go, that is completely ridiculous. But guess what? This attack is just as old, if not older, than this movie. And just recently, in Q4 of 2013, there was, and it was Checkpoint, had a vulnerability with OSPF. And there's one in Q1 2014, a second vulnerability with OSPF. So from an exploitation standpoint, if vulnerability research is your thing, and that's something that I think is pretty exciting, these are things that you should be targeting, and there's proof out there that it works. I just left the CVE in there just in case you wanted to go look it up, because I didn't want the talk to get too long. So that's one thing, that's route injection. But another attack that came out for Checkpoint was DOS via routing protocol. So you could send OSPF packets, and each packet is going to have a unique identifier, and you just duplicate the IDs one after another after another after another. That was enough to do a denial of service attack against a Checkpoint firewall and bring it down. Now, Checkpoint, fantastic hardware, fantastic software. I mean, it's Checkpoint. It's, for the longest time, their motto was "We secure the internet." They were the de facto firewall, still one of the best firewalls out there. And a simple OSPF packet could help you crash it. And again, that was really my spin on this entire thing. We've got the firewall that's out there stopping us from landing our 0-day. How is it doing it? Because it's so intelligent. We've got all these additional filters that are looking at, botnet command and control points. They're looking at, the deep packet inspection. They're looking at the reputation of our source IP address. And I go, I really just want that guy out of here. Remember my Kool-Aid logo. I want to crash this guy. I want to crash him again, once today. I want to do a DOS attack 4 times tomorrow. I want to do a DOS attack every 3 hours the day after that. I'm going to do it every 2 hours the day after that. So I've got 12 times a day. I'm going to keep DOSing again and again and again, and I'm going to make that target, the target organization, I'm going to make their IT team go crazy. They're going to go, what on earth is happening with this firewall? Is it corrupt memory? Why does it keep crashing? They're going to open a case with the vendor. The vendor's going to say, send us a core dump. They're going to scratch their heads because they're not exactly sure why it's happening, and even once they figure it out, they still have to write a patch. So at that point, the customer's vulnerable, and you can knock them down every time you feel like it. What's the customer going to do? Because uptime is more important than security to just about everybody on the planet, at least this is the way that my scenario that I'm trying to paint goes, is they pull the firewall out of the way, they place a simpler device like a router in the middle, give them some access lists, give them some network address translation, and they're just trying to keep their sites online. So I forecast, or I theorize, that they're not out trying to build zone-based firewalls with deep packet inspection, with HTTP protocol verification, because they're like, crap, it keeps going down, I've got stuff to do at home, I've got to get my kids to soccer practice, I've got to be on a conference call in 30 minutes. How do I keep these sites up to get everybody off of my back? So they tend to patch it by just putting the least sophisticated device in the way. Once that device is in the way, boom, our 0-day can go through and hit the server. So for the white hats, realize there could be crazy guys like me out here thinking that way and targeting you. So maybe if I could swap my Checkpoint with the Palo Alto or swap them both with an ASA, sure, they could be vulnerable, but hopefully it's a vulnerability that attacker isn't leveraging. So if you do have a system that's getting attacked, swap it for a different firewall. Don't put in a simpler device. If you're on the attacking side, hope that they're putting in a simpler device. They're going to leave the same ports open, and ideally you're going to be able to sail right through it. All right, next one is going to be multicast support. Multicast is one of those protocols that's been gaining a lot of popularity lately because people love video and they love high definition video. When you look at these 1080p video streams, I think a lot of the stuff we've been streaming around the house, at least if I put a file on a media server and I want to play it, off of my Mac Mini and stream it through a projector or so, I've looked briefly, and the bandwidth that it requires kind of bursts at times and goes up and down based on what's happening. But I see something, I don't know, in the range of like 12 to 18 megabits per second. If you've got lots and lots of traffic, lots of different video feeds, that just isn't going to scale very well. So multicast allows me, of course, to take that video feed, give it to lots of people at the same time. Multicast can be utilized for doing software updates. It can be used for system imaging, like good old Norton Ghost. We've used that in training centers before. People will use it for music on hold, and the Department of Transportation uses it for their CCTVs, so all the various agencies can tap into the video cameras that are up and down various roads in your organization. So if the firewall is built to support multicast and multicast is enabled, this can be interesting as well. There's a number of denial of service attacks that leverage multicast, and these are the types of things that I have found. Let's talk about one that I discovered, and I believe it's patched. It might still be vulnerable. I won't tell you who the vendor is, but I was doing a technical edit for, I believe it was Cisco Press, and in this tech edit, it was a multicast section, and the author says, multicast is always a destination address. It's never a source. And my inner dialogue went off. I said, this is the IT industry. No one ever says never, right? Because it always depends. There's always some weird condition. So I thought, I can't think of a practical scenario where multicast should be the source, but let me see what I can find. So I did the RTFM thing. I went out there, I started reading some RFCs, and you'll see that things like DNS, HTTP, when these firewalls do OSPF support, it's a standard. There's a paper on it that anybody can read, and the authors of the paper say this is how it should work, this is how it should not work. This is the range of acceptable values. Anything beyond that is not acceptable. So all that I did was looked at that, and every time I saw something that says this is not acceptable, I thought maybe this could create an unexpected condition, something that the programmer didn't write a line of code to handle, right? So I go, what happens if I do send a packet sourced from 224.224.224.224? The paper that I was reading at the time says this cannot exist. HPing would beg to differ. So if you're using HPing or Scapy or Comodia or whatever packet crafting utility that you want, when you send those packets out, you could just source it from a multicast address. Just because it's not supposed to happen, and I can't think of any logical reason for why it should happen. There's maybe a good one out there. I don't know what it is. But if that packet were to exist, how's the firewall going to react? And in my scenario, one single packet with a multicast source caused the firewall to core dump. That's all it took. One packet. Really pretty awesome. So that's a single packet denial of service. Now, if it sounds like, okay, Ryan, that's a little bit of a unique scenario, it's not. If you go to, just go to the web and just search for denial of service and put in your firewall vendor of choice and look at the number of vulnerabilities that are out there. There's new things all the time. Now, as the protocols get more sophisticated, it's just more things to break, and it's harder to protect against. So we all know what network address translation is. If you're watching this video, I know that you know what NAT is, but what you may not be aware of is that your firewall is opening up the packet. So remember, my envelope represents layer 2, layer 3, or layer 4 data. Inside, we have what I just referred to as the payload or 5 through 7 data. Now, what we're doing when we refer to deep packet inspection, I'm looking at what's going on in here. It's almost like your firewall is kind of like picking up the phone and listening to the conversation. He's eavesdropping, and sometimes the client will tell the server, hey, connect back to me on port 3000. Well, the firewall isn't forwarding port 3000. So by performing this deep packet inspection, he sees the client tell the server, I'm listening on port 3000. You know what? This client doesn't even know if port 3000 is available. So your firewall's doing things like looking for conflicts, and he's performing what is very simply just called a fix-up. He's looking inside of this and going, okay, well, 3000's going to have some incoming traffic, so I'll open port 3000. If there was a conflict, maybe he makes the port number 3030. He would write 3030 in the payload. He would fix the checksum for the message and then forward it on its way. So the fix-up protocol was really the beginning of deep packet inspection. This is something that the vendors had to do so that we could have firewalls that could support multimedia applications. Now, FTP is not the only one. There's lots of protocols, HTTP, SIP, Skinny, H323, TFTP, the list goes on and on. And while deep packet inspection was required to fix the embedded addressing, get this, sometimes a client will talk to a server. Let's say my computer's talking to your computer. We're chatting on Skype or AOL Instant Messenger or something like this. And all the messages go from my computer up to, I think last time I used AOL, it was like oscar.aol.com, and then it bounces back down. So all of our messages go through a central server until you transfer a file. The vendors who put out this chat software go, we don't want huge file transfers going through us. Let the clients connect directly. So when you try to initiate a connection with somebody else, your client software tells their client software, hey, I'm at 192.168.1.100 behind this Linksys firewall or whatever you got at home. Hopefully not that. There's a big worm going around today that's hitting all the Linksys devices. So let's hope it's something better. Go to Amazon, get yourself a little baby ASA 5505 and call it a day. Make sure you get a 50 user license. because you'll burn up those connections. And anyhow, back on track. We've got this packet. It's going up to the chat server, coming back down. The text is going back and forth until we want to directly connect. My computer says I'm at 192.168.1.101. Your computer goes, whoa, that's awesome, because I'm at 192.168.1.105. You've got an IP address overlap. And additionally, you're talking about an address that's not only local, but not routable on the internet. So it's kind of broken. When these issues first started to occur, at least for me, I started seeing this late 90s. You'd have, the users would talk. They're trying to use this application and say, hey, I try to connect and it keeps failing. I don't know what the deal is. And they'd go, oh, I'm behind a firewall. And you're like, oh, behind a firewall. It's almost like the car won't start. Why not? It's out of gas. And you're like, oh, I guess that's all there is to it. Well, the firewalls got smarter, and they have the ability to actually, like this guy is doing, he opens the package, he looks inside, and he fixes everything that he needs to. So if they're using pre-NAT IP addressing in the payload, he can actually fix that. Really pretty cool. So just some of the reasons that the vendors started to do this. And they go, well, if we've got to get in there and fix embedded addressing, why don't we start to look at other things? Why don't we look for signs of an attack? Why don't we verify that there's RFC compliance? In other words, when you look at a standard like SIP or HTTP or FTP, there's white papers that say this is how the protocol works. There's a specific order of operations. So we can validate that things are working the way that they're supposed to. This is just kind of a screenshot of an ASA and some of the things that he's looking at by default. I don't think the PPTP and ICMP were there by default, but everything else was. So if you're a firewall administrator, you should look at this and you should go, which of these things am I using? And you resort to rule 1A of all things computer security, which is if you're not using it, shut it off. Are you using NetBIOS? Maybe. Are you using it through your firewall? Definitely not. Kill it. Are you using RSH? No. Are you using RTSP? Probably. But I doubt that you're using both Skinny and SIP at the same time. What the firewall vendors are trying to do for you is, and I'm going to borrow a term from Scott Morris. This is the first time I heard this, which is automagic. It's making things automatically work. And my term for that is pixie dust. Pixie dust is going across the wire. It's just magic. We got our firewall. We put it in with some basic IP addressing. I picked up the phone call and it worked. The firewall administrator didn't have to think about SIP. He didn't have to think about Skinny. It was plug and play. Well, that's the mistake that Windows made back in Windows 2000. There were just exploits left and right. You had all these sappy DLLs that provided extra functionality to IS. IPP was one of them. You could not OPP. That's a different thing. Other people's packets, I think. IPP was the Internet Printing Protocol. So Internet Printing Protocol meant you could print to a web server over port 80. Kind of a neat thing, but why was every Microsoft web server waiting for print jobs by default? So of course somebody found that, they attacked the crap out of it and owned things everywhere. There were worms that leveraged this. It was very, very disruptive. So the vendors got smarter. Windows said, we look over there at FreeBSD and the FreeBSD guys have everything off by default. And an administrator has to come in and enable things one at a time. It's more administratively difficult, but it's exponentially more secure. So if you look at the firewall is a security device, but it's not secure by default. That is disruptive. I don't know. I don't even like the idea of that. So it's just something to be aware of. From the black hat side, realize there's a lot of things that are being looked at. From the white hat side, look at this list. Are you using SQL? Probably. Is it going through your firewall using SQLnet? If not, shut it off. Are you using Sun remote procedure calls? I doubt it. But maybe you are. Are you using XDMCP through your firewall? I don't think so. But, just shut it off. Shut off the things you don't necessarily need. If you're not sure, I would, if you don't know about the protocol, I'd read about it, look at what it's used for, maybe talk to the web developers and other folks within your organization. Say, hey, is anybody actually using this? What you might follow that up with is just a quick Google for any of these protocols. Look at their default port numbers, because that's the only place they're looking by default anyhow, and without setting up that port application mapping. And I could maybe write a very specific access control list that permits the specific port number of the application, and just watch for hit counters on it. run it for a week or two. If I don't see any hit counters, I go, nope, nobody's using it, shut it off. And this is why. This is just a quick screenshot from CVE details, but in the past 2 years, there have been multiple vulnerabilities in SIP, HTTP, SQLnet, DCE, RPC, which is our distributed computing environment remote procedure calls. And this is one of my favorite, most reliable exploits. There's most exploits in Metasploit are pretty reliable these days. But over the years, year after year, there's these RPC decom exploits that you can launch that just nail 99 times out of 100. There have been vulnerabilities just in the UDP inspection, inside of the SMTP inspection. You get the idea. So we want to make sure that our firewalls are always, patched to the latest stable version of code. And you take a look at these vulnerability advisories, and it's going to show you the versions of code that it affects. So just good food for thought, regardless of which side of the fence that you're on. Now, fuzzing firewalls. I talked to a lot of guys this week at B-Sides, and they go, really? Fuzzing network hardware? Like, how weird is that? Like, that seems so esoteric. How long does it take you to find a vulnerability? And I go, well, I don't really know the exact math because it was 8 hours and I found maybe 3. But there wasn't a lot in the first 4 hours, so I don't know, at least maybe 1 or 2 a day you could probably conservatively average. Depends on, how much experience you have and if you know where to look. But fuzzing, which is just kind of sticking arbitrary data in weird holes and seeing what happens, is no different with network hardware than it is in software. So if you're someone who's done exploit or vulnerability research, and we'll just leave it as that, against traditional software applications, it's really not much different against network hardware. The piece that I think is really nice is that when you target an application, the application isn't going to be as well documented as most of the network protocols. These are things that are very old, very well understood, and extremely well documented. So you can see the exact procedure and how it works. If you want to get ramped up on it, there's infinite YouTube videos that will show you, this is how the protocol works, this is how it operates, this is how it talks. So you can get a good base level understanding of it. If I want to attack a web application of a target organization, I don't know anything about their web application. They don't even have documentation on it, let alone anything that I can get to. They don't even have notes in their source code. So how does anybody going to make heads or tails of that application? So I think fuzzing, and I would really say I do manual fuzzing, right? Because I'll read about the protocol and I'll kind of get a specific area that I want to work on, and then I'll just start kind of digging away at that and see if I can find something. Yeah, I guess that's it. I'd say in the grand scheme of things, when you look at attacking network equipment and network protocols, it's significantly easier than targeting software applications. But I guess that's coming from a network admin and not a software developer. So your mileage may vary. And again, protocols are going to be well-defined. They're in RFCs. The inspection engines have expectations that are based on those RFCs. They assume that everybody's playing nice. They're going to validate your traffic as whether it's malicious or benign based on, are you playing by the rules? What they're not thinking about is protecting themselves. The firewall's job is to, protect everybody behind the firewall, but he sometimes forgets to look out for himself in the process. These inspection engines are limited and only analyze certain portions of data. This is where your mileage is really going to vary. When you look at different protocols, they can get into different capability, different levels of depth. Like HTTP, very, very sophisticated. If you look at things like SNMP, they can inspect it, but there's only 2 or 3 things that they look for. What you do here is you get the documentation from the vendor for their firewall, and you see what features and which fields are supported. Don't just fuzz everything out there. Know specifically what the inspection engine is capable of, and that helps you narrow your scope a little bit when you're trying to find that vulnerability. And then the way that it basically works is each protocol is going to have a header. The header has TLVs, and those TLVs are supposed to be certain types of data, like maybe a value of A through G and nothing higher. So just simply put a Z in there. See what happens. It's just that easy, not rocket surgery. So when we look at firewalls, they could be simple or they could be complex. Once upon a time, things were pretty simple. We had inside-outside DMZ, we looked at TCP flags, we maybe whitelisted some SMTP commands, fixed up DNS, and used ACLs. This is the type of firewall that, while not that effective for the end user, is not that easy to attack because that's not doing a whole lot. As you add complexity to the firewall, it is exponentially more sophisticated. But here's the thing. The average firewall that's shipping has got all this crap turned on. And the firewall administrators, they throw a couple IP addresses on it, change the login, open a few ports, and they let it run. So most firewalls, I would say, I think all statistics are made up, so why not make up some more? I would say, and this is leveraging my experience working with various customers and teaching a lot of clients and having conversations with them, I'd say definitely over 90% of the people that I've interacted with, and I train hundreds of people every year, and we talk about this stuff during class, they aren't using a lot of the features of the firewall. When I teach the firewall classes, I go, this is all the stuff it can do. Look, you can, whitelist specific HTTP methods, and their eyes go like this, and they go, is anybody actually using that? I'm like, I don't know, but if you're not, I'd shut it off. And that's really, I think, the message of this. It's been I'm not sure how long now, maybe, I don't know, half hour or so of me chattering, and it's just the basic theory of if you're not using it, turn it off, which is the same thing of locking down a server. I just don't know why people don't do it. So don't be vulnerable, don't get hacked, try to be as secure as possible, and shut that stuff off. So I hope you enjoyed the talk. The white hat benefits from the talk are kind of knowing what your firewalls can do. Cisco purchased IronPort several years ago, which gave them access to SenderBase, which was a global reputation scoring system on who's sending email. Now they've got something called SensorBase. They've got botnet filtering, which is, I don't know, last time I looked, maybe $100 a year for a subscription, worth every penny. You've got live signature feeds for your IPS. You've got the ability to do malware scanning. We've got web application filtering, NAT, protocol fix-up. All great things that we want to use. We want to turn on those features and just disable the ones that you're not using. Don't take away from this that my firewall is useless. You want to learn to use it more effectively. You want to read about those features, understand them, and enable them in a secure manner. You don't just want to leave it as default, though. The black hat challenges for you guys, what you're going to face is some trickery with TTLs like I described earlier, the fact that it's doing more granular inspection of things like UDP. This is problematic for me. One of my things that I kind of liked over the years was NSTX, which is, or iodine as they're calling it now, which is basically tunneling anything over DNS. I've tunneled IPv6 over IPv4 over DNS, and it's worked flawlessly. And DNS is one of those things that firewall administrators never tend to look at. They just tend to let it out. Because this can do more granular inspection of DNS, it's going to say, hey, something's wrong here. There's some type of tunnel data inside. These DNS requests are malformed. They don't look right, and it'll throw it away and break my tunnels. It also does protocol verification, which if you're trying to fuzz something behind the firewall, this can be really challenging. It's kind of like the firewall read the white paper, and he knows the rules. He knows how SIP works and how a session is established. And if you do things outside of that, he may throw it away. So it makes him more effective. But it's that same inspection engine, it's that same higher level processing that we want to leverage against the firewall itself to kind of crash it. So it's a dual-edged sword that's on fire and spinning. I would look at it as that. It's something that could hurt you, or it's something that could help you. Like I mentioned before, it can detect tunneling over HTTP. It can detect tunneling over DNS nowadays. So you've got ICMP left, and of course SSL always works. All right. So that's really what I think I've got for you. Closing note, if you're not using it, shut it off. And thank you guys so much for tuning in. I hope this was a good session for you.